Okay, what is continuity good for? Well, let me show you one good thing about continuity. The definition of the continuity is that x going to a of f of x is equal to f of a, right? It means that the limit is same as its value. That's what continuity means. Now, if you know some graphs are continuous, then this can tell you that all you have to do in order to find the limit as x goes to a is just evaluate the function at a. So for example, we all know that exponential functions are continuous. So if I had limit x going to 3, it's e to 3. Simple. To give you some list of continuous functions, polynomials are all continuous. Sine is continuous. Tangent is not continuous, right? Because if you think about the graph of the tangent, it has vertical asymptote. Anything that has vertical asymptote won't be continuous. So going back, sine, cosine, exponential functions, polynomials are continuous. And all their inverse functions are continuous. So inverse sine, inverse cosine will be continuous. Arc sine, that's another way to say sine inverse. So for example, if you had limit x going to 1/2 of arc sine of x, you can just simply evaluate arc sine at 1/2, and arc sine of 1/2 is pi over 6. So these are the questions that you can solve using the fact that a given function is continuous. Log ln is the inverse function of e dx, so that's continuous. So maybe I should write a list here. If f, g are continuous, then f plus g, f minus g, f times g, and f of g of x, this is composition, right? That's sometimes written as f circle g. F, the inverse function of f, if it exists, these are all continuous. What you have to be careful is, if you have f divided by g, then as long as g is not 0, this is still continuous. So this one, warning. G can't be 0. At points where g is 0, this won't be continuous. So other than this, if you have continuous functions, any sum of continuous functions, or difference, or product, or function composition, or inverse, these are all continuous. So you can make use of this property for very, very complicated functions. So here's a simple example. Well, it doesn't look that simple, but it is really not that bad. Say you have the limit of x going to 1 of cosine of ln of x. Okay. Now, because cosine is continuous and log is continuous on its domain, the composition of the two is continuous. So that means I can just plug in 1, and that's the limit. So in that case, cosine of ln of 1 is the limit. And what's log of 1? Log of 1 is, let's see, log of 1, really, log, ln means log with base e, and 1 is e to the 0th power, so they cancel and you get 0, right? So you get cosine of 0, and cosine of 0, if you draw the graph of the cosine, that's the graph of the cosine. So at 0, it's positive 1. So that's the value of this limit. So that's how you make use of continuity.